Hello friends, this is a 23-story building. We have to make it as seismic resistant. For that, go to define load patterns. We have to define the seismic load, make sure that auto lateral load is IS 1893-2002, modify lateral load. Here the parameters are considered as per Bangalore. So the seismic sound factor is 0.1, site type 2, Borden's factor 1, response reduction 3 and tick X and Y direction only. Click on OK. So after that, go to define load combinations. You can see that the load combinations are added. After that, we have to run the structure. So analyze, set load cases to run, make the wind load do not run, then run now. So we can see the displacement in 3D view. So after that, go to design, display. Using force stress diagram frame, you can view the shear and moment in different axes. So go to design, concrete frame design view, provides preferences. So make sure that the design code is IS 456-2000 and we have to check the design. So you start design check. Analysis and design section differ for 714 concrete frames. Do you want to reiterate analysis and design? You have to click yes. So the software itself make the structure safe. So after that, we have to go to design, concrete frame design, verify all members passed. Here all concrete frame passed with the design check. So after that, we can view the summary report and project report. So the seismic design is completed. Then now we are moving on seismic analysis on building using response spectrum method. For that, like in the previous case, we are checking whether seismic load is applied. For that, go to define load patterns. Here seismic load is added, and after that we are going to define functions response spectrum. So choose function type to add. So here we have to add IS 1893-2002. So add new function, name as response spectrum. So the seismic sound factor is 0.1. Type is 2. Click on OK. Then define load cases. Add new case. So we have to delete this one. Add new case. Name it as response spectrum. and type is also response spectrum, and click on add. The scale factor can be found using the equation Ig by 2R, and here it is 1663.5, and add one more, name it as U2. The same scale factor here also. So click on OK. Then we have to analyze the structure. Like in the previous case, do the same steps like analysis, check, set load cases to run, and make live load, dead load, and wind load not to run. Use only seismic load and response spectrum in run cases. Make it as do not run, and run now. And the last step we are going in this design, like after analyzing, go to design, context frame design, start design check, and after that go to verify all members passed in the previous case. So the last step is seismic analysis of building using time history method. Like in the previous case, check whether the load pattern is given, define load patterns, verify whether the seismic load is given. In that case, use only X direction is tick. You have to tick only X direction, and the seismic zone factor is 0.1, R is 3, type is 2, and importance factor 1 as in the previous case. So after that we have to go to define functions time history. Define functions time history, and we have to choose the file from this file and add new function. You have to import the file here, browse, and name it as time history. And after clicking OK, we can run the analysis. So after that, you have to go to define load cases and add new case. So here I am deleting this. Add new case, name it as time history. Type is also time history, and use add option and select acceleration U1. Scale factor can be found using equation Ig by 2R. So here type 1663.5. so apply OK. And like in the previous case, we are analyzing the structure, set load cases to run, make the dead and live load do not run, and the response spectrum also do not run, and we can get the results. This is how we design a seismic resistant building using time history method and response spectrum method. Thank you.